So let's go to today's material on loops. Actually, let me go to the PowerPoint first, because I have some animations or simple animations in here to help present some of this. And just a reminder about flowcharts, because you'll start seeing flowcharts in some of our presentations now. And just to remind you how to interpret a flowchart. So the arrows are showing the sequence of execution of the program. And there are different symbols that mean different things. So usually an oval means start or stop. A diamond means making a decision or branching. And so maybe it's an if statement. And there are going to be two directions it can go, because whatever condition is put here is going to be either true or false. If it's true, you go one way. If it's false, you go the other. A rectangle just means doing some operation like a calculation. And so in this case, if count is an even number, you do this operation. Otherwise, you don't actually do anything. You just skip that, and then these two branches come together again. And sometimes there's a sort of junction symbol that goes here. Then we do some other operation. And now we're doing another decision, is count greater than 20, and then branching backwards. Whenever you see branching backwards, that usually means it's a loop. It might be a for loop or a while loop, but there's typically some kind of loop here. Okay. And then stop. And so a diamond could be an if statement, as it says here. It might also just be part of a loop. Here's a simple example. This BMI calculation we've done a couple of times. So you ask the user to enter his height and weight. So here's another symbol you'll see sometimes. This parallelogram usually means getting input from the user. Calculation, and then a branch. So is BMI greater than 30? If yes, we go one way. And this symbol usually means output, like printing something to the command window. And what this represents is tearing off a piece of paper from an old-fashioned printer. I've done that, you probably haven't. All right, so that's what that shape means. If it's not true, then you go the other way. And I just had to bend it around to make it fit on one landscape slide. Go to the next branch. If that's true, you go this way, you print overweight, and then you skip to the end. Otherwise, you go to the next one. Right, and then they all come together here with these junctions. So that's what this symbol means. This is just multiple branches coming together, and then finally it stops. All right, so that's just a reminder about flowcharts. All right, so MATLAB, like most programming languages, has two different types of loops, for loops and while loops. Usually you do a for loop when you know in advance how many times you're going to execute the operation. If you don't know in advance, or it's hard to determine in advance, you can use a while loop, which just keeps going until some condition is met. So this is an illustration of how a for loop works. So if I asked you, what does a for loop do based on your prior experience? You would probably say, execute some block of code a fixed number of times. And that's true, but more fundamentally, what it really does, it iterates over an array. You give it some array, and it performs some operation, some block of code for each element of that array. Now, one way of using it is to do something a fixed number of times. But to remind you of the syntax, it's going to look like this. So there's always going to be, of course, the word for. And there's always going to be some variable. That's always the next thing that appears. That's a common mistake we see with beginners is they'll just do something like for 1 colon some other number. And they'll forget that they have to put a variable here. What goes to the right here of the equal sign is it's actually an array specification. Now, the simplest case is where you just have 1 colon some upper limit, like in this case, 1 colon num students. But this can be any kind of array specification. And what it's going to do is repeat this block of code between the for and the end for each element of that array. So what you're really doing in this case, you're creating the array. Since num students is 4, it's 1, 2, 3, 4. And you're feeding that in reverse order. 1, 2, 3, 4. Okay. So the variable I is going to take on each of these values, and then we're going to do whatever is in this block of code. All right, so first it loads in the number 1. So I is 1, and it does this, which is just going to print out I see 1 students. We can make this a little better by putting an if statement here. So if I is 1, it only prints out student instead of students, but we didn't want to complicate it. All right, then it asks the question, have we reached the end of the array? Which means there are no values left over here. Well, we haven't, so it branches backwards. It loads in the next value, which was 2. So now I is 2. It repeats this, and it's going to print I see 2 students. Haven't reached the end of the array yet. There are still more numbers over here, so it branches back. Loads in 3. I see 3 students. Still not done. There's one more value here. Loads that in. I equals 4. Prints I see 4 students. And now when it checks, there's nothing left over here. Now we're done. So it just goes on to whatever comes next in the program. Right, so that's basically what a for loop really does. You give it some array, and it repeats whatever is in this block of code for each element of that array. Now, when you're iterating over a data array, iterating just means repeat the code for each element of that array. You should get out of the habit of hard coding the number of elements. Like in this case, V is 5, 6, 7, 8, 9, 10. 5, 6, 7, 8, 9, 10. There are 6 elements. I could have put 6 here. But it's really a much better practice not to hard code that number. Use the length function to let MATLAB figure out how many elements there are. Because that way, if you change it, okay, let's say we make this 12. Now this becomes 8. Right? Well, I don't have to edit this. It's really much better. Use the length function. And even if this changes, well, this will update automatically, essentially. Okay, it'll always iterate over however many elements of this array there are. And so that's for vectors. If it's a vector, use length. If it's a matrix, use size. And size will give you the number of rows and the number of columns for a matrix. There are actually higher dimensional arrays that you can do, but in this class, we just do 1 and 2 dimensional. Okay, so 2-dimensional matrix size will give you the number of rows and the number of columns. All right, so this says for k equals 1 to s of 2, which is the number of columns. So it's going to loop over however many columns there are in this matrix, which in this example means it's going to print out the whole second row. All right, so use length and size. Don't hard code the size of an array. All right, let's go look at the examples. All right, so I'm going to show you several examples of for loops, showing you the different ways you can use them. The first one is where literally you just want to do something a fixed number of times. And in this example, what I'm going to do is I'm just going to take the square root of a number 3 times. So randomly generate some number, initialize the output variable to be the same as that number, and then take the square root 3 times in a row, which means I'm taking the 8th root. All right, and we end up with, whoops, sorry, it was supposed to be a 3. I changed that yesterday just for illustration purposes, so that was supposed to be 3. All right. So the 8th root of, and I spelled 8th wrong. The 8th root of 3736 is 2.796. Okay. So in this case, the loop variable, the counter, k, serves no purpose other than to keep track of how many times we did it. We're not using it in this block of code in any way. It's just counting. All right, and then you saw, I always ask people then, what if I put in 100 here? What will I get? And you already saw this, the answer turns out to be 1. Right? No matter what you start with, if you take the square root enough times, you'll end up with 1. Because if the number is greater than 1, you take its square root, it gets smaller. If it's less than 1, you take its square root, it gets bigger. So as long as you start with a positive number, you will eventually get to 1. All right, so that's the first example of a for loop. Do this so many times. Now, sometimes, again, I changed this in my last class. Let me put it back to what it was originally. Sometimes the variable here not only keeps track of how many times you've done it, but it is the numbers on which you're operating. So in this case, I'm actually taking the square root of k. So k is not only the counter, it's the data I'm operating on. All right, so I get the square root of 1, 2, 3, 4, 5. But it doesn't have to be just a sequence. I can put any set of numbers here I want. Any way I can specify an array, I can put it here. So I can just put arbitrary numbers here. Right? And it'll give me the square roots of those numbers. Okay. So you can specify an array here either just with the colon operator or just literally listing the numbers, or you could use linspace, or you might be reading in some data file. Okay. Then the third way of using a for loop is where you're iterating over one or more data arrays. Actually, while I think about it, let me change this back for my next lesson. All right, so we have some data arrays, heights, weights, and names, just like previous examples we've done. And I calculate the BMI values. And here I chose to calculate the BMI values in one line with array operations. Yeah, I calculated them all at once. And now I'm just going to loop over all of the subjects here and print out the person's name and their BMI value. All right, so what role does the loop variable here play? In this case, it's an index. Okay, so I'm using person, and just to switch things up, I chose to call it person, just to make the point. It's just a variable. You can call it anything you want. And I'm using that as an index into names and BMI. All right, so the first time through the loop, person is going to be 1. I'm going to print the first name and the first BMI value. Second time it's going to be 2. I print the second name and the second BMI value, and so forth. All right. And again, I use the length here because that way I can come back and add more data. Okay, and I don't have to edit this. Okay, or if I was loading this in from a data file, okay, I wouldn't know offhand how many elements there were, but I can just find out using the length or size function. Okay. Now, any question about any of those examples? All right, let's try one. Take 2 minutes and make a for loop to print out. So we're just generating an array X at random here. And notice I'm randomizing the size, so you cannot hard code the number of elements because it changes every time you run it. So loop over the elements of X in steps of 2 and print out X of 1 plus X of 2, X of 3 plus X of 4, and so forth.